In this video, let us see about how to wire a home distribution board and the nameplate details available in a MCB. Do not try to do the wiring at home without any expert advice. This is the main distribution board for our home. So we need an energy meter followed by the main switchboard. So this energy meter will be used to measure our power consumption. Let us see the wiring diagram for the single phase main distribution board. So we have the utility pole. From the utility pole you have to connect the energy meter. So the energy meter, since it is a single phase, we can take this type of meter where we will have 4 terminals, out of which 2 are for input and 2 for output. So the energy meter can be any type. So here the terminals will be marked which is input and which is output. So let us connect the energy meter here. So one line, that is the phase, and neutral we can take it as input, and these two lines will go to the main switchboard. The output of the energy meter should be connected to the dual pole MCB. So to the bottom line we are connecting the output of the energy meter, and the other end of the MCB will be connected to the load. Load also has two terminals, line and neutral. In our home there will be many loads will be there. Each load can be connected through a single pole MCB. So this is single pole MCB. So we have to connect the load through this switch, so that whenever there is a fault current, this will trip and isolate that particular load. Now this switch needs input which is a phase line. So we can use a common bus bar, and you have to give all these switches needs a phase line. So let us connect it. So from here connect the line wire here. Then through a common bus bar all the switches can be connected. So this helps to reduce the manual connection here. Next, to the other terminal of the MCB we have to connect the loads, or line of the load is connected from the other end. So we can see here the line wire is connected to the load through a switch. So whenever any fault occurs, this will trip. Then we have one neutral here in the load, as well as here one neutral is there. So we can connect using a neutral link. All these things will go to the load. So different loads, we will connect all the neutral of the loads to the neutral link. In addition, we have to connect the appliances to the earth. So you can use a earth link which can be connected to the earth electrode. We have seen how to wire a single phase main distribution board. It is very simple and easy to wire. But how to select the MCB for your requirement requires knowledge about the MCB. There are lot of MCBs are available in the market. How to choose the MCB for your particular requirement? So for that you should know what is written over the MCB. So let us see what is written on the MCB and how to choose an MCB for your requirement. There are two options to know about the MCB. One thing, you can download the datasheet and read it. If that is difficult, from the nameplate details or by reading the data given in the MCB, you can get some knowledge about the MCB which you are using. First thing is the graphical symbol. So in any MCB, if you take this type of symbol will be there. So what is this symbol? This represents it is a circuit breaker. So I have taken a double pole MCB. So two legs are there and they are interconnected. So this type of graphical symbol will be there in all MCBs. So here I have taken a SPN. So though it appears like a double pole MCB, this is not double pole, it is SPN. That is single pole with neutral. Now you see the graphical symbol of this one. You can see the difference. Here one pole is not protected. Only one pole is protected. So knowledge about this graphical symbol will help you to understand what type of MCB you are having in your hand. Okay. First we will see what are the graphical symbols used to represent a circuit breaker. So here 1P represents the single pole breaker and 2P represents the double pole breaker. So these are some of the symbols used to represent the circuit breaker. So whatever we have seen previously is of this type they have used. And the circuit breaker, if it provides magnetic protection, thermal protection, it is represented like this. If it has both thermal and magnetic protection, it can be represented like this. So here it is for a double pole, the same thing, but two poles will be represented with the interlocking. So here also double pole, it will be like this. An MCB is designed to protect against both overloading as well as short circuit. So these two are two different processes. Under overloading condition, the temperature increases and a bimetallic strip bends so that the MCB gets tripped. So thermal tripping is used for overload protection. For short circuit protection, a solenoid and a plunger is used. When a short circuit current flows, the solenoid gets activated and it moves the plunger. So due to that, MCB gets tripped. If you see the graphical symbol here, two lines are there. So for circuit breaker, we know this is the symbol. Two lines represents the two pole and it shows that both are same. It means that protection is there in both the poles. In addition, you have some rectangular section which represents that it has thermal protection, as well as this one represents it has magnetic protection. If you see the graphical symbol of residual current circuit breaker, so RCCB, we know it is a current sensing device because it will sense the current, leakage current. So this is used for protection from electrical shock and earth falls. So here you see the picture, it is like a loop. It means that it is sensing the current. So for each device there is a different set of graphical symbol used. And for isolator, we know isolator means there is no protection. It is used to isolate a particular part of the circuit from the rest for repair work. So it is normally manually operated. So you see the symbol here, it will be like this, showing that there is no protection. Next we will see about the on-off switch in MCB. So we can see here these are all MCBs which are in on position except this one. So all these MCBs can be turned on manually. That is, if you pull up, it will get turned on. Whenever there is a fault, it detects any fault, it will come down automatically or turned off automatically under fault conditions. After the repair work, you can make it to turn on manually. So this represents the off position and this one represents the on position. So here I have shown two MCBs. One is in off position. You can see clearly off is written here and this is in on condition. Upward position is on condition. So you can see it is on. Now there are also, in addition to this on off switch, here two things are here which is called status indicator. So here this is in green color, here you have it in red color. So this breaker is in off position. Green means off condition. It means that it is safe to work. But here you see it is in red color. This is breaker is in on position. So red color on condition. So it is unsafe or danger to work with this MCB. Next is how to identify the terminals, that is where you should connect the line and where you should connect the load. So or you have to do it in the other way, that is a big question. So now we will see the types of MCB so that you will understand where you can connect it. So there are two types. One is called non-polarized. Non-polarized means there is no polarity, and polarized means polarity will be there. So here in non-polarized MCB you can connect anywhere. You can connect the line and load here or you can connect it anything here. So it is bidirectional. So most of the MCBs, normal MCBs which we use are bidirectional. If you are not sure about whether it is bidirectional or not, you can also refer to the data sheet where they might have specified that no line load bias. It means that you can connect it anywhere. But normally bidirectional MCBs, nothing will be marked in the MCB. Next we will see another MCB. You see in this side, so this is the front view, and you see in this side they have mentioned what is load and what is line here. It means that at the bottom you have to connect the line and at the top you have to give the load connection. So in this type of MCBs you cannot reverse the connection. So always line should be connected at the bottom and load at the top. You take some other manufacturer, here also they have specified same thing. Bottom you have to connect the line and top you have to connect the load. The thing is, this is the front view and in MCB side view you will get this information. Apart from this, you have DC MCB where they will mention the polarity as plus and minus will be there. So here for double pole it will be plus minus, minus plus will be there. So this I have taken from a data sheet from L&T. The connection diagram they have given for these two MCBs. So you see here single pole 1. So in single pole we have seen pluses at the bottom. So they have taken this plus here. Connect to the plus of the battery or DC source. Let us take it as a battery. So the plus of the battery will be connected to the plus of the MCB. And minus of this MCB should be connected to the positive terminal of the load, and the negative terminal of the source is connected to the negative terminal of the load. So for these two MCBs they have given the connection. Similarly for a double pole you have plus and minus. So plus and minus here. So the DC source is directly connected like this. the load positive and negative should be connected accordingly. Okay. Next we will see the nameplate details. So first you have C25 is written here. What is this C25? C stands for the type of MCB. So we know there are different types of MCB. B, C, D are the widely used one. Though there are different types, B, C, D is widely used one, and B type means it will trip at 3 to 5 times the rated current, and C type will trip at 5 to 10 times the rated current, and D type will trip at 10 to 20 times the rated current. So B and C mostly used for residential purpose, and D is used for industrial purpose, or that high inrush current machines like X-ray or large motors, you can use class D. So if you want to details about this, you can see the previous video on house wiring which I have given in this Read Electric Vehicle channel. So now this C represents that this MCB belongs to class C. That is, it will trip when the current is between 5 to 10 times the rated current. So what is the rated current? 25 amps is the current rating of this MCB. So we have here B type MCB. So B10 means it is B type and current rating is 10. So here you have D16 and here it is K125. So it belongs to class K. Normally this type is used for submersible motors. Next we have, we will see about the current rating. So here C25 we saw it is a current rating. So here you see C6 means it 6 amps MCB. Let us see about the available current ratings of MCB in the market. Mostly from ratings 1 amps to 63 amps are available. So you can see here these ranges are available. So it is available in all the 4 models, that is single pole, double pole, triple pole, as well as in 4 pole configuration it is available. Here the last 2 digits represents the current. 63 represents 63 amps, and this one represents the whether it is single pole, double pole or triple pole. So you can see here 3, in 4 pole it will be 4. So this is not a standard one, it varies with respect to manufacturer. So you can see here C32 amps and this is C63 amps. Next we will see how to select a particular MCB for an appliance. This is the data sheet given in this website. So this is applicable only when we use Havells MCB. So they have clearly mentioned it varies from manufacturer to manufacturer. So this you can take it as a reference and you will get some knowledge about choosing the MCB for your appliance. So if you take air conditioner, depending upon the capacity of it, you can choose the current rating, and preferably they are using C type MCB. And for refrigerator also they are using C type, but amp requirement, current requirement is less. So similarly for each appliance you can choose the current rating of the MCB depending upon your power rating of your device. So we have seen about the current rating and type of MCB. Next we have the rated voltage or the operating voltage of this particular MCB. Then we have the IEC standard printed on it. It means that this MCB has subjected to the different test specified by this IEC standard. Normally this IEC standard is applicable for breakers operating at 50-60 Hz, 440 volts and rated current 125 amps and short circuit current of 25 kilo amps. So this breaker is suitable for residential purpose. If it is to be used in industry, it has to be certified by different standards. So the difference is that in a residential building, the exposure of the MCB to pollution is less, whereas in industry it will be exposed to different chemicals, vibration, dust, it will be there. So the MCBs, when it is used for industrial purpose, it has to undergo different set of tests so that it will be safe for the customers to use in industries. Next we will see about the breaking capacity of the breakers. So here 6000 is written in a box. Here it is 10,000. It means that this is 6 kilo amps and this is the 10 kilo amps. So that represents the maximum short circuit current that the breaker can handle without damaging. So this 6000 amps or 6 kilo amps is suitable for domestic and commercial application. For industrial application, we have to go for a higher short circuit current, because in a residential building, normally the maximum fault current will be less than 6 kilo amps. So this type of breaker is preferred. But if the load is very high, like in industry, the short circuit current may be very high. So in such cases, you have to go for a higher rating. Next we will see about the energy class. So this is represented by the letter 3 here. So we know energy is power into time, which is given by I square R into time. If R is constant, we can write energy is directly proportional to I square into T. So what does this means? Whenever a fault occurs, the tripper takes some time to completely trip. So this current into that time will contribute to the energy. So the breaker should respond as fast as it can, or it cannot let more energy, so it will damage the breaker. So this energy should be very low. So according to IEC, if you see, there are 3 classes, out of which most of the breakers are of class 3, which will allow only very little energy to flow through the breaker during the faulty condition. So this class 3 is said to be the best condition or the best class for the breaker. So always prefer this 3 type MCB for your home. An MCB is designed to protect against overloading as well as short circuit. A normal simple thermal overload type circuit breaker is usually bidirectional. It means that you can interchange the line and load terminals. Normally type B and C MCB is used for residential purpose, and the current rating you can choose according to your load, and always choose breaking capacity of 6 kilo amps for your house, and if the load requirement is high, you can choose 10 kilo amps, and choose always energy class 3. In addition to this, if you need any other information in detail, you can mention in the comment section so that I will give it as a separate video. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.